Hello everyone and welcome back to another video, and today we'll be working January 2018 statistics question, which is section 5 of the syllabus, and this comes in question 7 from this paper. And here it goes. It says the marks obtained by 10 students in a test scored out of 60 are shown below, and they gave us the 10 marks, which is 29, 38, 26, 42, 38, 45, 35, 37, 38, and 31. And it says for the data above, determine the range. So what we know is that range is equal to the difference between the highest and the lowest. In this case, it will be the difference between the highest score and the lowest score. So what we can do, we can identify what these are. The highest score is equal to 45, and the lowest score is equal to 26. So therefore, our range for this data set is equal to the highest minus the lowest. It will be 45 minus 26, and when you do that calculation, you will get 90. So the range for this data set is equal to 90. Part 2 of the question now says we should determine the median. In order to determine the median, what we know is that our data must be in some form of order, usually either an ascending order or descending order. So what I'm going to do is to arrange it in ascending order. I'm going to arrange our data set in an ascending order fashion. So ascending order. So that would be, so we're starting from our lowest number to be 26, then 29, then 31, 35, 37, 38, 38, 38, 42, and then 45. Looking at this, if we were asked to determine the mode, we know that mode is the number that occurs the most. Just additional information. So our mode for this data set would have been 38, but that's beside the point. So they asked us to determine the median. So we know that median is the middle number. So there's usually a formula that we can use to find the position of the median number. So what that usually looks like is Q, which is median, is equal to n plus 1 divided by 2, where n is the number of events that is taking place. In this case, it would be 10, because it is 10 students. So these are the scores obtained by the 10 students. It will be 10 plus 1 divided by 2, and that would be 11 divided by 2, which would give us 5.5. And remember, this doesn't tell us what the median is, it tells us the position of the median number. So because we get a decimal, what we know is that our median number is between the 5th and the 6th value. So there are two numbers basically in the middle position, occupying the middle position. So what we need to do is to find the average of these two numbers, and that will give us our median. So it will be 1, 2, 3, 4, 5. So it is the 37 and the 38 that occupies the middle number. So therefore, our median will be the average of these two numbers. So therefore, what this will look like is median is equal to 37 plus 38, and that is divided by 2. And so let me just extend this a bit so that you can see it. So it will be 37 plus 38, and that will give us 75 divided by 2, which is equal to 37.5. So our median score is 37.5. So that is it. So once usually we use a formula to determine the median position. Once it is a decimal, what this is indicating to us is that there are two numbers in the middle and we need to find the average of them. Our next question asks us to find the interquartile range. So if you remember what interquartile range is, it is the difference between the upper quartile, which is Q3, minus the lower quartile, which is Q1. And basically, the upper quartile, it's when the data set is divided into two using the median. So the numbers that are on the right-hand side, all of those are in the upper portion of our data set. So you now need to find the median for that upper portion, and that is your Q3, which is your upper quartile. And for the data that is now on the left of our median, that occupies the lower portion of our data set, you need to find the median of that, and that will give you your lower quartile. So let's show you what exactly that will look like. So using our data set still arranged in ascending order, so our data set still arranged in ascending order, what we know is that our median was not any of these numbers. So therefore, if we should insert that, the 37.5, I'm going to change the color for that so that we know that it is not a part for data sets. I'm going to make it red, I'm going to make it bold and a little bigger. So therefore, the numbers that are on the upper part, every number here is a part of the upper portion of now the data set. So this is Q2, which is our median. So this 37.5 is our median. We now need to find from this upper portion of the data set what is the median. So from 38 to 45, we need to find what is the median here. So there are 5 numbers. So 1, 2, 3, 4, 5. So therefore, the median is easy to identify. So what we know is that it would have been the third number that is the median, which in this case is 38. So therefore, our Q3, which is our upper quartile range, so Q3 is equal to 38. So that is the, so let's change the color as well for that to make it easier to identify, or just highlight it. That's easier, 38. So that is our upper quartile range. And then for the lower portion of the data, so from 26 to 37, we're looking for the median for this portion of the data, and that would have been 31. So therefore, this now is considered Q1, which is our lower quartile. So, and Q1 is equal to, let's get it in that, and Q1 is equal to 31. So now we can go ahead and calculate our interquartile range, which is equal to Q3 minus Q1, which then would be 38 minus 31. So from our data set, we already know what our median is. So since neither 37 or 38 was a part of the median value, which when calculated to be 37.5, they will be counted when finding the lower quartile and upper quartile. So we found the upper quartile from the upper part of our data set, which is from 38 to 45, to B38, which is Q3, and from the lower portion, which is from 26 to 37, we found that Q1, which is our lower quartile, to be, so it should be Q3 minus Q1, and this is Q1. So Q1 is equal to 31, and our interquartile range, the formula for that is Q3 minus Q1, which our Q3 is 38, Q1 is 31, and therefore when we do this subtraction, what we'll get is 7. So our interquartile range is 7. So it is the upper quartile, which is Q3, minus our lower quartile, which is Q1, and that gives us our interquartile rate. Part 4 now asks us the probability that a student chosen at random scores less than half the total marks in the test. So let's go back up to see what the test was marked out of. So it's 10 students in a test scored out of 60. So this test, the total marks, the maximum marks on this test is 60. So the question says the probability that a student chosen at random scores less than half the total marks in the test. So let's just take back our numbers here in the same ascending order so it is easier to analyze. So if our test is marked out of 60 and we're looking at probability, let's first look at the formula for probability. So what we know is that probability is the frequency of the event. So probability is equal to the frequency of the event, or the frequency of the possible outcomes, or the number of outcomes divided by the total event. In this case also, the frequency of the event divided by the total frequency. So it can be the number of possible outcomes divided by the total outcome. So in this case, there is 10 outcomes. So now we need to find out, or the frequency is 10, if you want to look at it that way too. So we're looking at, that is the total, what are the number of possible outcomes, so, or the frequency of the event. So the event that we're looking at is the number of students that score less than half of the total marks in the test. So the total marks is 60. So half of the total marks would have been 30. So we're looking for how many students scored less than 30 in the test. And that will give us there are only 2 students, which is those that scored, that student that scored 26 and the other student that scored 29. So therefore it would be 2 over 10. And that would have been our probability. And we know that from section of the syllabus, when it comes down to fraction, whenever we can simplify, we always do that. This can simplify to give us a 1 over 5. So our answer can be as a fraction, or we can express it as a decimal. So what we do is 1 divided by 5, and that will give us 0.2. Or we can express it as a percentage, which would give us 20%. So those are the 3 possible answers. So 1 over 5, or 0.2, or 20%. So therefore, probability in this case, it is the number of students who scored less than 30 divided by the total number of students. It's the number of possible outcomes divided by the total outcomes. So there are 10 outcomes, that's the total. The number of possible outcomes is 2, as there are only 2 students that scored less than half the total marks in the test. And that is our answer for part 4. Part B now says the frequency distribution below shows the masses in kilogram of 50 adults prior to the start of a fitness program. And they gave us, this is 1, 2, 3, 4, 5, 6 class intervals. And they gave us the corresponding midpoint and the frequency. And it says on the grid, using a scale of 2 centimeters to represent 5 units on the x-axis and 1 centimeter to represent 1 unit on the y-axis, draw a frequency polygon to represent the information in the table. So we're going to go to our graph. So I am using this to be our graph. So we're looking at scale. It says using a scale of 2 centimeters to represent 5 units on the x-axis. So 2 centimeters to represent 5 units and 1 centimeter to represent 1 student on the, well, did it say student? No. in a kilo of 50 adults. So 1 centimeter to represent 1 adult. On the y-axis. So we're plotting our frequency polygon. And what we know is that when we're plotting frequency polygon, we usually extend our polygon or line to the horizontal axis. So we basically estimate the mass, or the midpoint in this case, that would come before this first value and the one that would come after this value. So we're estimating those midpoints and correspond those with frequency of 0, which should make our frequency polygon ends and the start on our horizontal axis. So in this case, what it means is that for this, the class interval before this would have been 55 to 59. So therefore, our midpoint for that would have been 57 with a frequency of 0. So it would have been 57 with a frequency of 0. And then we have a midpoint of 62 with a frequency of 8. So a midpoint of 62 so it'll be somewhere here, because this would have been 63. So 62 with a midpoint with a frequency, of 8. So somewhere right here. And then next we have, so we did this one, so let's just mark it up. Next we have 67 as the midpoint with a frequency of 11. So we use midpoint to plot frequency polygons. So we have a midpoint of 67 to a frequency of 11. Actually, for the 57, it wouldn't have been on this line, it would have been a little before it. So it would have been 57 with a frequency of 0. So this was 67 with a frequency of 11. The next one would have been 72 with a frequency of 15. So 72 with a frequency of 15. The next would have been 77 with a frequency of 9. So 77 with a frequency of 9. And then 82 with a frequency of 5. So 82 with a frequency of 5. And then 87 with a frequency of 2. So 87 with a frequency of 2. And again, we will end our frequency polygon on the horizontal axis. So the next class would have been 90 to 94. So our midpoint would have been 92 with a frequency of 0. So 92 with a frequency of 0. And that is somewhere here where our points have been. So now what you would do, since you have your graph paper in front of you, is to take your ruler and to draw straight as possible lines for these and connect them. But since I don't have a ruler using the physical graph leaf, I'm just trying to draw these lines as straight as possible. So this is what your frequency, something similar to this with more accuracy, is what your frequency polygon will look like. And this will be your frequency polygon, and you will get your 6 marks. And that is the end of this question. So thank you for joining us, and we will see you next time.